whenever the function is in the denominator and its derivative is in the numerator, with respect to dx can be written as log of f of x plus c. Integral of cosecant cot is minus cosecant x plus c. So this is the integral value. Remember here 2 sin square x by 2 can be written as 1 minus cos x. So therefore this is integration of 1 minus cos x into dx. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. So let's take few problems in this session by the method of substitution. The standard integrals here, few of them are given here. So integral of tan x dx can be written as log of secant x in terms of modulus. It's a positive quantity, hence we have taken modulus there. It can be written as log of secant x plus c. You can also verify, if you derive log of secant x, you will get 1 by secant x into derivation of secant x is secant x tan x. That is why integration of tan x can be referred as log of secant x plus c. Again, cot x can be written as log of sin x plus c. Whenever you get integration of cot x, you can directly write it as log of modulus of sin x. Similarly, integration of secant x. We know integration of secant square x, that is tan x. But integration of secant x can be taken as log of modulus of secant x plus tan x. And integration of cosecant x can be taken as log of cosecant x minus cot x, because we know integration of cosecant square is minus cot, as well as integration of cosecant and cot is minus cot, as well as integration of cosecant and cot is minus cosecant x. So therefore here integration of cosecant function is log of cosecant x minus cot x plus c. So other than these standard integrals, we have learnt many standard integrals of all trigonometric function, algebraic function, e power x and log function, and few more standard form of integrals which I have taught in the previous session is, so any function in the form of f of ax plus b into dx can be written in the form of 1 by a times, so if this is the derivative, its function can be written as some f of ax plus b plus c. And one more function, integration of f of x and its derivative along with its derivative, so can be directly written as f of x whole to the power n plus 1 by n plus 1 plus c. So whenever the function and its derivative are inside the integral, we can take f of x and f dash of x, or both inside the integral. We can take the function in the form of f of x to the power n plus 1 by n plus 1 plus c. And other than this, we have any function in this form f of x. Whenever the function is in the denominator and its derivative is in the numerator, with respect to dx can be written as log of f of x plus c. I can just write log of f of x also, which is one and the same. I have used modulus here. So this is one and the same. So these are some standard form of integrals you can generally use without simplifying the steps also. So these are the form of integrals we have solved in the previous session. We'll continue all the usage of these integrals in trigonometric functions also. Let's take trigonometric functions and their integration in this session now. Integrate the following function with respect to x. So first one is integral of sin x into sin of cos x dx. So again we are going to use the substitution method. Therefore here clearly you can see, you can put cos x is equal to t. Then derive it. Derivation of cos x is minus sin x dx is equal to dt. Now here we need sin x into dx. So this becomes minus dt. So in the place of sin x dx, just write minus dt, and in the place of cos x put t, so that it becomes sin t. Now we got minus integration of sin t dt What is the integral of sine? Integral of sine is minus cos. So we get it as minus of minus cos t plus c. So minus of minus cos t is cos t plus c. What is t? We have taken cos x. So therefore cos of cos x plus c is the integral value of the given function. Next, sine cube x into cos square x dx. So here let me take sine cube x as in the form of sine x into sine square x into cos square x dx. So here we know that sine square x can be written as 1 minus cos square theta. So therefore this can be written as sine x into 1 minus cos square x into cos square x dx. So here sine x. So here we can take cos square x minus cos power 4x into dx. Now we will make the use of substitution. Put t is equal to cos x. Then dt is equal to, so what is derivative of cos x? It is minus sin x dx. So therefore I can take minus dt as sin x dx. So in the place of sin x dx, I can substitute minus dt. So then it becomes integral. We can take minus outside, and in the place of cos we can put t. So therefore this is t square minus t power 4 into dt. Now apply the integral for each variable separately. So if you have t square, this is t cube by 3, and if you have t power 4, it is t power 4 plus 1, that is 5 by 5 plus c. Now replace back, or you can take t power 5 by 5 minus t power 3 whole divided by 3 plus c. Replace what is t. So we have taken t as cos x. So therefore cos power 5 times x divided by 5 minus cos cube x divided by 3 plus c is the integral value of the given function. So next we have integral of 1 over sin x cos cube x dx. So on simplifying, this function can also be written in the form of sin x divided by cos cube x plus 1 over sin x cos x into dx now. So next here we have, this is the integral. So here we have sin x divided by cos cube x plus 1 over sin x cos x. So next is here we have integral of, here we have sin, cos is repeated 3 times. So sin by cos can be written as tan x, and 1 by cos square x can be written as secant square x. So when you multiply dx here, this is one separate integral and this is one separate integral. And here again plus integral, divide both the numerator and denominator by cos square x. So this becomes sin x cos x divided by cos square x into dx. So what happens here? Integral of tan x secant square x dx plus integral of 1 over cos square can be written as secant square x. Sin by cos can be written as tan x, and cos get cancels. So into dx. Now here let us make a substitution. Put t is equal to tan x. Then dt is secant square x into dx. So in both the function secant square dx can be replaced with dt, and tan can be replaced with t. So it becomes integral of t into dt plus integral of dt over t. So now integral of t is t square by 2, and 1 over t can be written as log t plus c. So what is t we have taken? That is tan x. So this is tan square x by 2 plus log of tan x plus c. So this is the value of the given integral. Next, integral of 1 over cos square x into 1 minus tan x. So here put 1 minus tan x is equal to some t. Then derive it. This is 0 minus tan x is secant square x. So secant square x dx is equal to dt. Now here I need secant square x, but here 1 by cos square can be written as secant square x. So secant square into 1 minus tan x. So 1 over cos square is secant square and this is 1 minus tan x into dx. So here it becomes, now in the place of secant square dx, I need to substitute minus dt because I have negative here. So let me take minus outside, then I'll substitute dt and 1 minus tan x I have taken as t. So therefore this becomes minus log t plus c, or I can take log, what is t I have taken? 1 minus tan x plus c. So this is minus. So minus log of 1 minus tan x plus c. Next one is sin cube x plus cos cube x divided by sin square x plus cos square x. So here divide both the numerators separately with the denominator. So we have sin square x cos square x plus cos cube x divided by sin square x cos square x into dx. So here sin square x cancels. So I'll get sin by cos square x. So cos square can be written as cos into cos. Sin by cos becomes tan x and 1 by cos becomes secant x. And here cos square x cancels. So cos by sin become cot x and 1 by sin is cosecant x into dx. Now we know that integral of secant x into tan x is secant x. So therefore this becomes secant x. Integral of cosecant cot is minus cosecant x plus c. So this is the integral value. Next one, evaluate the following integrals with the help of trigonometric identities. So trigonometric identities are very necessary sometimes when we are integrating multiple functions, half angle functions or any kind of transformation formulas. So there we are going to use the multiple angles formula, transformation formula, allied angles formula, which are necessary so that we can reduce them into standard form and then write the respective integral. So here is such kind of problems we have. First one, evaluate the integral sin 2x into cos 3x dx. So we have this in the form of sin c sin d form. So how this can be written? So now first question is, evaluate the integral sin 2x cos 3x into dx. Now this is in the form of sin a cos b. So we know the formula, that is 2 sin a cos b can be written as sin a plus b plus sin a minus b. You know the formula for sin a plus b and sin a minus b. When you add them, you will get 2 sin a cos b. Now this is in the form of sin a cos b. We don't have to, we can shift here so that it becomes half of sin a plus b, means this is a and this is b. So what is a plus b? This is 5x. Next is plus a minus b we need. So that is sin 2x minus 3x becomes minus x. So this is into dx with respect to the integral symbol. So I can take half outside. So here I'll get integral of sin 5x. Sin of minus x is minus sin x. So therefore that is minus sin x dx. Now integrate both the values separately. So we can take half as a common factor. What is integration of sin 5x? We know that f of ax plus b is there, means with respect to dx, then it can be written as 1 by a times f of ax plus b where this is the original function of this derivative. So what is integral of sine? Integral of sine is cos function. So but this is in the form of ax plus b, therefore it is 1 by 5 times cos 5x. Next, again minus, what is integral of sin x? Again integral of sin x is minus cos x. So here it is minus 1 by 5 cos 5x, and here also it is minus cos x, which becomes plus cos x plus c. So when you multiply this, you can write this as minus 1 by 10 cos 5x. Next here plus 1 by 2 cos x plus c. So this is the given value of the integral. Next we have cos 4x into cos 6x. So let us use the formula 2 cos a cos b. 2 cos a cos b is nothing but cos of a plus b plus cos of a minus b. Now I can shift 2 here, so it becomes half of cos a plus b plus cos a minus b. So here I can take integral of cos 2x into half of cos a plus b. So this is a and this is b. So here it becomes cos of 4x plus 6x is 10x. Next we have plus a minus b, means it is cos of 4x minus 6x becomes minus 2x. So this is into dx. Now here we have integral of cos 2x into, so 1 by 2 times cos 10x minus plus cos of minus 2x, or cos of minus theta is cos theta itself, so that it becomes cos 2x into dx. So next we can take half outside, and here again we get integral of cos 2x into cos 10x plus cos 2x into cos 2x is cos square 2x, and with respect to dx here. So next here we can multiply half to both functions also. So I have taken it outside. So I can take it as half integral of cos 2x cos 10x into dx plus half integral of cos square 2x into dx. Again we can apply the transformation formula of cos a plus b and cos a minus b. So here I can get half into half cos of, so here we have 2x and 10x, so that it becomes 12x plus cos of minus 8x. So, and here we got integral value also here inside with respect to dx. Next here, in this case, this is in the form of cos square 2x. We know the multiple angle formula, that is cos 2x can be written as 2 cos square x minus 1. So that means 1 plus cos 2x can be written as 2 cos square x, or cos square x can be written as 1 plus cos 2x divided by 2. So in the place of x, replace 2x. So put 2x here. So what happens? Cos square 2x is equal to 1 plus cos 2 into 2x is 4x divided by 2. So in the place of cos square 2x for the second integral, replace it by 1 plus cos 4x divided by 2. So therefore here the second integral becomes half integral of 1 plus cos 4x divided by 2 into dx. Now let us integrate each one separately. We have half, and here we have separately integral of, I can take half outside here also. So cos 12x into dx. Next we have plus half integral of cos of minus 8x is cos 8x only into dx. Next again we have half. I can take half outside so that it becomes 1 by 4. 1 by 4 into integral of 1 into dx. Again plus integral of cos 4x dx. So now let's take here. So 1 by 2 becomes 1 by 4. Integral of cos 12x is sin 12x. So therefore sin 12x divided by 12 we can take because it should be in the form of 1 by a. Next again multiply 1 by 2 into 1 by 2 becomes, here also it is 1 by 4. So plus 1 by 4 cos 8x can be written as sin 8x divided by 8. Next here we have 1 by 4. So 1 by 4 integral of 1 is x. Next again we have 1 by 4 integral of cos 4x is sin 4x divided by 4 plus c. So here you can see 1 by 4, 1 by 4, 1 by 4, 1 by 4 as a common factor. So in each term, so you can take 1 by 4 as a common factor, you will get sin 12x by 12 plus sin 8x by 8, and you can rewrite this as sin 4x by 4 plus x as constant plus integral, constant of the integral which is c. So using the transformation formulas, you have to reduce this into sum form. You have a product form, convert this into sum form, again multiply the cos 2x, again apply the transformation formula, convert it into summation form, then integrate each value separately and write their particular standard integrals. Next one, integral of cos square x dx. So I have already told you in the previous problem, that is cos square x can be written as 1 plus cos 2x divided by 2. So here I'll just replace it by 1 plus cos 2x divided by 2 into dx. So therefore this becomes integrals of 1 by 2 dx plus integral of cos 2x by 2 into dx. So this becomes half, integral of dx is x, here is half, so plus half into cos 2x is sin 2x by 2 plus c. So therefore it is 1 by 2x plus 1 by 4 sin 2x plus c. So this is the value of the integral. Next, cos 2x minus cos 2 alpha. So next we have integral of cos 2x minus cos 2 alpha divided by cos x minus cos alpha into dx. So here we can use the formula cos c minus cos d, which can be written as minus 2 times sin c plus d by 2 sin c minus d by 2. So this is the transformation formula, sum or difference to product of the integral. So let us apply for both numerator and denominator. It becomes cos 2x minus cos 2 alpha becomes minus 2 times sin 2x plus 2 alpha divided by 2 sin 2x minus 2 alpha divided by 2. Similarly in the denominator, minus 2 sin x plus alpha by 2 sin x minus alpha by 2. So integral with respect to dx we have minus 2 get cancels. Numerator can be written in the form of sin x plus alpha sin x minus alpha whole divided by sin x plus alpha by 2 sin x minus alpha by 2. So we also know the multiple angle formula, that is sin 2x can be written as 2 sin x cos x. So if you write this in half angle formula, this becomes, that is half of this angle Sin x can be written as 2 sin x by 2 cos x by 2. So use the same formula here also. So in the place of x, you have x plus alpha, so that it becomes 2 sin x plus alpha by 2 cos x plus alpha by 2. So just replace here. This becomes 2 into sin x plus alpha by 2 cos x plus alpha by 2. And here, next we have sin x minus alpha. So in the place of x, you just replace with x minus alpha. So here it becomes 2 sin x minus alpha by 2 cos x minus alpha by 2 whole divided by, in the denominator we have sin x plus alpha by 2 sin x minus alpha by 2. So with respect to dx, we are going to integrate it. So we can clearly see in sin x plus alpha by 2, sin x plus alpha by 2, sin x minus alpha by 2, sin x minus alpha by 2 get cancels. So we are left with 2 2s are 4. We can take it outside. 4 integration of cos x plus alpha by 2 and cos x minus alpha by 2 into dx. Now again this is in the form of cos A, cos B. Cos A, cos B can be written as cos A plus B plus cos A minus B. So therefore it is 4 into 1 by 2 times cos of A plus B, means it is x plus alpha by 2 plus x minus alpha by 2 plus cos x plus alpha by 2 minus x minus alpha by 2 into dx. Here we can cancel by taking outside. So 4 into 1 by 2 becomes 2, and here integral of cos. So here we can clearly see denominator is same. So alpha minus alpha get cancelled. 2x by 2 becomes x. And plus we have here x minus x. So x minus x get cancelled. Alpha and plus alpha becomes 2 alpha. 2 alpha by 2 is cos alpha. Cos alpha into dx. Next we have here 2 into. What is integration of cos x? So cos x is sin x. So the first one is done. Next we have integration of cos alpha. Do not write it as sin alpha because alpha is a constant. So obviously cos alpha becomes a constant function. So integration of constant with respect to dx is x into constant. So that this becomes x into cos alpha. So plus c. So this is the integral value of the given function. So here use cos c minus cos d formula for both numerator and denominator. Again, in this step, you are going to use half angle formula of sin x. Then again, you are going to use cos A, cos B transformation formula so that you can simplify it. Then you can get the standard form of integrals. Next question we have integral of sin square x divided by 1 plus cos x. So here also I am going to use the half angle formula, that is sin x can be written as 2 sin x by 2 cos x by 2. And we know that cos x can be written as 2 cos square x by 2 minus 1, or we can write 1 plus cos x as 2 cos square x by 2 and 1 minus cos x as 2 sin square x by 2. So remember this half angles formula, which is very important in solving identities like this. So in the place of this we have sin square. So if you square it, it becomes 4 sin square x by 2 cos square x by 2. And in the denominator you have 1 plus cos x. 1 plus cos x can be written as 2 cos square x by 2 into dx. So cos x square by 2, cos x square by 2 cancels. So 2 1s are, 2 2s are get cancelled. So we can write 2 sin square x by 2 into dx. Remember here, 2 sine square x by 2 can be written as 1 minus cos x. So therefore, this is integration of 1 minus cos x into dx. Now integrate it separately. Integration of 1 into dx minus integration of cos x into dx. So integration of constant with respect to dx is x, and here it is integration of cos x is sin x plus c. So this is the integral value of the given function. Next question we have integral of sine inverse of cos x into dx. So here put cos x is equal to t here. Then what happens? Minus sin x into dx is equal to dt. Or I can write dx is equal to minus dt divided by sin x. Remember, sin square x can be written as 1 minus cos square x, or sin x can be written as 1 minus cos square x under the square root. Here I have taken cos x as t. So therefore here sin x can be taken as root of 1 minus t square. So therefore in the place of sin x, I'll just replace it with minus dt divided by root of 1 minus t square, because different variables cannot be derived at the same time. Therefore, whenever it is expressed in dt, better you express sin x in the form of t only using that relation. Now here, then integral becomes sin inverse of cos x is we have taken as t, dx can be written as minus dt, so I'll take minus outside, dt divided by root of 1 minus t square. Now you can see this f dash of x and f of x are in the same integral. So which can be expressed again by substitution. So here put sin inverse t is equal to some u. What is the derivative of sin inverse t? It is 1 over root of 1 minus t square into dt is equal to du. So put and replace it back. So you will get minus integral of sin inverse t is u and this complete thing is du. So it is u into du. What is integral of u? U square by 2 plus c. What is u? U we have taken as sin inverse t whole square divided by 2 plus c. But what is t? T we have taken as cos x. So therefore it is minus sin inverse of cos x whole square divided by 2 plus c. So this is the integral value. So these are all few examples of integration by the method of substitution as well as using trigonometric identities. We'll meet you in the next session with other types of integrations. Until then, keep watching, keep learning, keep exploring. Thank you.